Good afternoon to everyone. So today we are going to discuss about these greenhouse gases. So the gases are responsible for the greenhouse effects. So that is called greenhouse gases. Or I can say in simple sentence, what is that? Heat trapping. Heat trapping. Heat trapping gases. So all these heat trapping gases are called as greenhouse gases, right? So basically, the greenhouse gases are a group of compounds, right? So there are lots of gases that are able to trap heat in the atmosphere, right? So the greenhouse gases, when present in moderate quantities, help Earth retain the heat received from the sunlight, right? So thus helping in maintaining moderated temperature and necessary for survival of life on Earth, right? So these greenhouse gases are good, but if they are in the right quantity, right? So they form a layer around the Earth, which acts like sort of light blanket. So when sun rays are reflected into the Earth, some of these rays are absorbed by the Earth, right? So you see here now. So what are the greenhouse gases? Greenhouse gases are those gases which absorb the long wave radiation emitted by the Earth's surface, right? And these greenhouse gases are radiated this energy in different directions, right? Different directions, thereby warming the Earth's atmosphere, right? So that means these greenhouse gases are crucial for the survival of life on planet. But excessive presence of greenhouse gases in the atmosphere that leads to overwarming of the atmosphere and leading to permanent climatic changes in the form of global warming. So the main gases responsible for the greenhouse effects, those greenhouse gases are first one is carbon dioxide, and second one is methane and water vapor, ozone, nitrous oxide, fluorinated gases, and also carbon monoxide. So these are the important greenhouse molecules or important greenhouse gases. That means heat trapping gases, right? So the carbon dioxide, methane, and water vapor. So these three. These three. So these three are the very most important greenhouse gases. And that is to lesser extent and surface level of ozone and nitrous oxide and also fluorinated gases also trap infrared radiation, right? So now you can see one by one. You see these are the atmospheric gases. Carbon dioxide. Carbon dioxide means one carbon, two oxygens. That is called CO1C and two oxygens, right? So carbon dioxide enters the atmosphere through which one? Burning burning of fossil fuels. So what is that? Coal, natural gas, and also oil, right? And also solid waste and trees and other biological materials, and also as a result of certain chemical reactions, right? So the carbon dioxide is removed from the atmosphere when it absorbed by plants as part of the biological carbon cycle, right? So the carbon dioxide is the primary and most significant greenhouse gas, right? So the carbon dioxide is naturally present in the atmosphere as part of the Earth's carbon cycles, right? So carbon dioxide plays a critical role to the increasing the Earth's temperatures, right? So Earth needs a balance of greenhouse gases to maintain just the right temperature for living things, right? So it allows the sun rays to pass through the atmosphere, but prevent infrared heat radiation and reflect by the earth from the escape into our space and redirect heat back towards the earth, right? So due to this temperature of the atmosphere is increasing, right? So the carbon dioxide contributes approximately how much? 88%, right? 88% to the warming of the world or globe, right? So hence the global warming is identified mostly with the increase in carbon dioxide emissions that has with human and natural activities, right? So now more than 60%, right? More than 60%. 60% of carbon dioxide emissions are caused by this burning of fossil fuels and cutting down and burning trees and thermal power plants and automobiles, and also deforestation. So account for about 20% of the carbon dioxide increase from the human activities, right? So half of the carbon dioxide emitted by the which one? Human activities, right? So now the human activities are altering the carbon cycle, both by adding more carbon dioxide to the atmosphere, right? And by the influence the ability of natural things, right? So like forests and soils, and to remove and store carbon dioxide from the atmosphere, right? So significant natural sinks include terrestrial vegetation, which takes up carbon dioxide during photosynthesis, right? Photosynthesis. So while carbon dioxide emissions come from the variety of this natural sources and also human related emissions are responsible for the increase that has occurred in the atmosphere since the industrial revolution. Remember this word, industrial revolution. So what is this industrial revolution? So in modern history, this process of change from an agrarian and handicraft economy to one dominated by industry and machine manufacturing, right? So this process began in Britain. In the 18th century. And some they spread to other parts of the world, right? So although that is used earlier by French writer, the term industrial revolution was first popularized by the English economic historian, that is the Arnold Tony, T-O-Y-N, Tonby. So the year of 1852 to 83. So to describe Britannia's economic development from the 1760 to 1840, right? So the several processes are also produce carbon dioxide emissions through chemical reactions, that do not involve combustion, and examples include the production of mineral products such as cement, and the production of metal such as iron and steel, and the production of chemicals, right? So the main human activity that emits carbon dioxide is the combustion of fossil fuels, right? What is that? Combustion of fossil fuels, right? So for energy in transportation, so although the certain industrial process in land use changes also emit carbon dioxide, okay? So now transportation. So the combustion of fossil fuels such as gasoline and diesel to transport people and goods was the largest source of the carbon dioxide emissions, right? So this category includes transportation sources such as highways and passenger vehicles, and also air travel, marine transportation, and rail. So almost 95%, right? 95% of the world's transportation energy comes from petroleum-based fuels and largely gasoline and diesels, right? And then next we are going to electricity. So electricity is a significant source of energy, and it is used to power homes, business, and industries, right? So the combustion of fossil fuels to generate electricity was the second largest source of carbon dioxide emissions, right? So the types of fossil fuels used to generate electricity emit different amounts of carbon dioxide, and to produce a given amount of electricity, burning of coal will produce more carbon dioxide than natural gas or oil. So now coming to industry. So many industrial processes emits carbon dioxide through that fossil fuels consumption. That fossil fuel consumption means fossil fuels burned on site and facilities for energy. So these sectors are also include emissions from chemical and metallurgical and mineral transformation processes not associated with energy consumption, and emissions from waste management activities, right? So one important point is here, emissions from industrial electricity use are excluded, and those are instead covered in the electricity and heat production sectors, right? So now you see here this graph, it shows the progressive increase in this carbon dioxide concentrations over the past 5 decades, right? So the concentration of carbon dioxide in the atmosphere is now over 400 parts per million. So which is represents a greater than here how much? 20, right? 20% increase since the 1960s, right? You see here 320 to 340. So this is the 20. And also here 20. And also here 20. So this is the greater than 20% increase since the 1960s, right? So you see this increase in carbon dioxide concentrations as well as other greenhouse gases such as methane. So that is directly related to an observed increase in global temperature. So you can observe on the graph here. So this process is called global warming, right? So as the planet warms, it causes changes in regional climates, right? So this is commonly referred to as climate change, right? So now we are going to methane. Second one is methane. So methane is the second most important in the greenhouse gases. So methane means 1 carbon and 4 hydrogen. That is CH4. It's called CH4, right? So methane contributes approximately how much? 18% to total radiative forcing by long-lived greenhouse gases, right? So the human activities emitting methane include leaks from natural gas systems and raising of livestock. So methane is also emitted by natural sources such as natural wetlands. So in addition, the natural processes in landfills. So in soil and chemical reactions in the atmosphere, it helps remove methane from the atmosphere. So methane is emitted from which one? Energy, right? And industry and agriculture and land use and also waste management activities. So and also generated by bacteria that is called what is that? Methanogens, right? Methanogens. So which is habit in marshes, swamp and wetland soils, right? So methane gas escapes from garbage landfills. Which one? Garbage landfills and open dumps also. So it also leaks out during mining and extraction and transportation of coal, oil and natural gas, right? Coal mining is also a source of biggest methane emission, right? So the methane's lifetime in the atmosphere is much shorter than carbon dioxide. But methane is more efficient at trapping radiation than this carbon dioxide, right? So the comparative impact of one molecule of methane is 25 times. How much? 25 times greater than CO2 over 100 years period. How much? 100 years period, right? So the approximately how much? 50 to 65% of methane or 40% of methane is emitted into the atmosphere by natural sources and 60% of total methane emissions come from human activities, right? So in this methane, agriculture. So agriculture is domestic livestock such as cattle, swine, sheep, and goats. So those are produce methane as part of their normal digestive processes. So, and methane is produced when animal manure is stored or managed in lagoons or holding tanks, right? So you remember here, so one cow can produce 73,000 liters per year. So as a part of the normal digestive process, right? So about 65% of cow manure is composed of methane and making it an abundant energy resource because humans raise these animals for food and other products, and the emissions are considered human related, right? So the agriculture sector is the primary source of methane emissions. Now, energy and industry. So methane is the primary component of natural gas and petroleum systems, right? So these are the second largest source of the methane emissions in some of the countries, right? So some amount of methane is emitted to the atmosphere and during the production and processing and storage, transmission, and also distribution of natural gas, right? So next, waste from homes and business. So methane is generated in landfills as waste decomposed and in the treatment of waste water, right? Waste water. So landfills, these are the important things in your examination. So they are asking, describe about these landfills, right? So you listen carefully. So these landfills are the third largest source of methane emissions, right? So methane is also generated from domestic and industrial wastewater treatment and from composting and anaerobic digestion, right? So the methane is also emitted from a number of natural resources, sources, right? Natural sources. So natural wetlands are the largest source emitting methane from bacteria, so that decompose organic materials in the absence of oxygen, right? So, and also smaller sources, those are include termites, oceans, and also sediments and volcanoes and wildfires, right? Next one is nitrous oxide. So it means N2O, so one oxygen and two nitrogens. That is called N2O, right? So this is the third most significant greenhouse gas, right? So it contributes approximately how much? 6%, right? 6% to total radioactive forcing by long-lived greenhouse gases. So now, this gas is produced naturally from human activities. About how much? 60%, right? So human activities such as agriculture, fuel combustion, and also waste management and industrial processes. So those are increasing the amount of this nitrous oxide into the atmosphere. So nitrous oxide is also naturally present in the atmosphere as part of the Earth's nitrogen cycle and bacterial activity in the soil, and it has a variety of natural sources, right? So the impact of one molecule of N2O on warming the atmosphere is almost how much? 300 times. 300 times that of one molecule of carbon dioxide. How much? 300 times. So remember this. So now we're going to, in nitrous oxide, agriculture. The nitrous oxide can result from various agricultural soil management activities, such as application of synthetic and organic fertilizers, and also other cropping practices. So the management of manure or burning of agricultural residues. So these are also various agriculture soil management activities, right? So the agricultural soil management is the largest source of nitrous oxide emissions, right? Next, fuel combustion. So nitrous oxide is emitted when fuels are burned, right? Fuels are burned. So the amount of N2O emitted from burning, right? Burning fuels. So that is depend on the types of fuel and combustion technology, maintenance, and also operating practices, right? The next, wastewater management. So nitrous oxide is also generated from treatment of domestic wastewater during nitrification. What is that? Nitrification and denitrification. The nitrogen present, right? So it is usually in the form of urea, right? What is that? Urea and ammonia, and proteins, right? Proteins. And next we are going to industrial processes. So now nitrous oxide is generated as a byproduct during the production of chemicals, right? So such as nitric acid, which is used to make synthetic commercial fertilizer, and in the production of adipic acid, which is used to make fibers like nylon and other synthetic products, right? So the nitrous oxide emissions occur naturally through many sources. It is associated with the nitrogen cycle, right? So which is the natural circulation of nitrogen among the atmosphere, plants, animals, and microorganisms that live in soil and water, right? So the nitrogen takes on a variety of chemical forms throughout the nitrogen cycle, including nitrous oxide. So natural emissions of nitrous oxide are mainly from which one? Bacteria. Bacteria breaking down nitrogen in soils and the oceans. So nitrous oxide is removed from the atmosphere when it is absorbed by certain types of bacteria or destroyed by ultraviolet radiation or chemical reactions, right? Then next we are going to next greenhouse gas is water vapor, right? It's called H2O. H2O. So one oxygen, two hydrogens. That is called H2O, right? So not OH2, H2O. Okay. So the most abundant greenhouse gas in the Earth atmosphere is water vapor. Right? So, most of the greenhouse heating of Earth atmosphere is due to water vapor absorption of infrared radiation emitted by the Earth, and then transferring the energy to the surrounding air molecules. So the water vapor is the biggest overall contributor to the greenhouse effect in the atmosphere. So it is the most important greenhouse gas, right? So, but humans are not directly responsible for emitting this gas in quantities sufficient to change its concentration in the atmosphere, right? So, however, the carbon dioxide and other greenhouse gases is increasing the amount of this water vapor in the air by boosting the rate of evaporation, right? Then next we are going to ozone. So all are three is oxygens, that is called O3, right? So ozone is technically greenhouse gas, right? But ozone is helpful or harmful depending on where it is found in the atmosphere, right? So ozone occurs naturally at higher elevations in the atmosphere. So that is the stratosphere, right? So where it forms a layer that blocks ultraviolet light, which is harmful to plants and animal life from reaching to the earth surface, right? So the protective benefits of stratospheric ozone outweigh its contribution to the greenhouse effect. What is that? Greenhouse effect and global warming. So, however, at lower elevations of the atmosphere, that is troposphere, ozone is harmful to humans, right? Human health. So now, O3 is the one of the biggest contributors to the greenhouse gases, right? So ozone layer helps in the absorption of most of the toxic ultraviolet rays from the sun, right? So the ozone is found to be present on the which place? Top surface of the stratosphere, right? And around how much? 30 miles, right? Around 30 miles higher than the ground surface where it helps the earth, right? So whereas around 12 miles higher above the troposphere. Troposphere, that is 75 to 85% of Earth atmosphere, about 12 to 18 kilometers high. So the ozone behaves as a greenhouse gas by trapping heat. So similarly, in the middle section of the troposphere, the ozone assists in cleaning up some pollutants, right? So it is 2,000 times as effective as carbon dioxide in heat retention proper, right? So this is the ozone. And then next one is fluorinated gases. So fluorinated gases also known as F gases, right? And these are synthetic and powerful greenhouse gases that are emitted from a variety of industrial processes such as aluminum and semiconductor manufacturing. And fluorinated gas are often used as substitutes, right? Substitutes for ozone depleting substances, right? So the fluorinated gases are sometimes used as substitutes for stratospheric ozone depleting substances, right? So these gases are typically emitted in smaller quantities, but because they are powerful greenhouse gases, right? So with an even higher warming potential than carbon dioxide, right? So sometimes they are referred to as high global warming potential, that is called high GWPs, right? High global warming potential gases, right? So the fluorinated gases do not, remember this one, do not produce from natural sources. So that is only comes from human related activities, right? Human related activities. So that is used in a range of everyday products, as well as in industrial applications, right? So they can also have long atmospheric lifetimes. So in some cases, the lasting thousands of years, right? So most of the fluorinated gases are well mixed in the atmosphere and spreading around the world after they are emitted, right? So the many of these fluorinated gases are going to remove from the atmosphere, so only when they are destroyed by sunlight in the fair upper atmosphere, right? So in general, these fluorinated gases are the most potent and longest lasting type of greenhouse gases emitted by human activities. So however, the fluorinated gases are powerful greenhouse gases with a global warming effect up to how much? This 23,000 times. 23,000 times greater than carbon dioxide, right? And their emissions are rising strongly, right? So now you see here, we have main categorized as these fluorinated gases are, first one is hydrofluorocarbons. This is the first one, hydrofluorocarbon. And second one is perfluorocarbons. And third one is sulfur hexafluoride. And fourth one is nitrogen trifluoride. So first one is hydrofluorocarbons. It's called as HFCs, right? HFCs. And perfluorocarbons means PFCs. And sulfur hexafluoride means SF6. And nitrogen trifluoride means NF3. Right? HFCs, PFCs, and SF6 and NF3. So these are the four main fluorinated gases are here. Now, so the hydrofluorocarbons, first one is hydrofluorocarbons. So these are the substitution for ozone depleting substances. Right. So the hydrofluorocarbons, these are used as refrigerant and aerosol and propellants, and also foam blowing agents, solvents, and fire retardants, right? So the major emission sources of these compounds in their use as refrigerants, right? What is that? Refrigerants. So, for example, in air-conditioned systems in both vehicles and buildings, right? So, these chemicals were developed as a replacement for chlorofluorocarbon, CFCs, and hydrochlorofluorocarbons, CFCs and HCFCs, because they do not deplete the stratospheric ozone layer, right? So first one is hydrofluorocarbons and hydrochlorofluorocarbons. So these two are being phased out under the international agreement. So that is called the, what is that? Montreal Protocol. Montreal Protocol, right? So the hydrofluorocarbons are potent greenhouse gases with high global warming potentials, right? What is that? High global warming potential. That is called GWPS. And they are released into the atmosphere during manufacturing processes. And which one? Through leaks and servicing and disposal of equipment in which they are used, right? Then next one is hydrofluoroolefins. So that is called HFOS, right? So these are developed and these are a subset of hydrofluorocarbons, and those are characterized by short atmospheric lifetimes, right? And lower global warming potentials. So the hydrofluoroolefins are currently being introduced as refrigerants and aerosols and propellants and foam blowing agents, right? Next, perfluorocarbons. So these are the compounds consisting of fluorine and carbon, right? Fluorine and carbon. So perfluorocarbons are produced as a byproduct of aluminum smelting processes, and these are used in the manufacturing of semiconductors and cosmetics and also pharmaceutical industries, as well as in refrigeration when combined with other gases, right? So the perfluorocarbons are generally have long atmospheric lifetimes and GWPS, that is global warming potentials, they are 10,000 years. 10,000 years. So this is the lifetime period of perfluorocarbons. And then next one is sulfur hexafluoride. Sulfur hexafluoride. So it is used in magnesium processing and semiconductor manufacturing. So as well as a tracer gas for leak detection also, right? So this HFC 23 hydrofluorocarbons 23 production, and it is used in a semiconductor manufacturing. So HFC 23 is produced as byproduct of hydrochlorofluorocarbon 22 production, right? And this is used in semiconductor manufacturing, right? So this is the sulfur hexafluoride in perfluorocarbons. And transmission and distribution of electricity, that is sulfur hexafluoride, is used as an insulating gas in electrical transmission equipment and including circuit breakers, right? Circuit breakers. And nitrogen trifluoride, it is used mainly primarily as an etchant, right? etchant for microelectronics fabrications, right? Microelectronic fabrications. So this is the percentage contribution of various anthropogenic greenhouse gases emissions at global level. So this is the level in the year of 2010. But so IPCC report in the year of 2014, you see here the IPCC report 2014 as per this 2010 level. So in carbon dioxide percentage is 65. Total how much? 65%. And carbon dioxide, this is fossil fuels and industrial processes. And second carbon dioxide is forestry and other land, right? And methane is 16% and nitrous oxide is 6%. And also other fluorinated gases are 2%. So this is the report of IPCC 2014, the global level of 2010. Right? Now, what are the causes of global warming? So now, these are many causes of global warming. Some are natural or some are man-made causes. So that warming is a danger for the existing of life on the earth. You see here, first one is man-made causes of global warming and natural causes of global warming. So global warming causes two types, man-made and natural, right? So first one is man-made. What are the man-made causes? Right? So deforestation, use of vehicles, and chlorofluorocarbons, and industrial development, and agriculture, and also overpopulation. So these are the man-made causes of the global warming. So now we can define one by one. So first one is deforestation, right? So deforestation means plants are the main source of oxygen, right? So all of you know about this. So they take in carbon dioxide and released oxygen, thereby maintaining environmental balance, right? So the forests are being depleted for many domestic and commercial purposes, right? So this has led to an environmental imbalance. So thereby giving rise to global warming, right? So use of vehicles. So that is the use of vehicles even for a very short distance results in various gases emissions, right? So vehicles burn fossil fuels which emit a large amount of carbon dioxide and other toxins into the atmosphere and resulting in a temperature increase, right? And chlorofluorocarbons. So with the excessive use of air conditioners and also refrigerants, right? And humans have been adding chlorofluorocarbons into the environment, which affects the atmospheric ozone layer. So the ozone layer protects the Earth's surface from the harmful, which rays? Ultraviolet rays, right? Ultraviolet rays emitted by the sun, right? So the chlorofluorocarbons have led to ozone layer depletion, is making way for the ultraviolet rays, thereby increasing the temperature of the Earth, right? Next one is industrial development. Just wait. So in the year of 2013, so the Intergovernmental Panel for Climate Change, that is IPCC, right? IPCC report that the increase in the global temperature between 1880 to 2012, it has been how much is 0.9? How much? 0.9 degrees Celsius, right? How much? 0.9 degrees Celsius temperature has increased. So the increase is 1.1 degrees Celsius when compared to the pre-industrial mean temperature, right? So then next we are going to agriculture. Agriculture. So the various farming activities produce carbon dioxide and methane gas, right? So these add to the greenhouse gases in the atmosphere and increase the temperature of the earth, right? Next one is overpopulation. Overpopulation. So an increase, overpopulation means over growing birth, right? Birth growing rate. So an increase in population means more people breathing, right? More people means more people. So this leads to an increase in the level of carbon dioxide, right? So the primary gas causing global warming in the atmosphere. So more people means what happens? So more people leads to an increase in the level of carbon dioxide, right? So these are the man-made causes of global warming. And then next we are going to natural causes. What are the natural causes of global warming? Those are volcanoes, water vapor, melting permafrost, and forest blaze. So these are the important natural causes of global warming. So now one by one you see volcanoes. Volcanoes means volcanoes are one of the largest natural contributors to global warming. So the ash. So from volcanoes, what is that? It will come ash and smoke, right? So the ash and smoke emitted during volcanic eruptions, that is goes out into the atmosphere and affects the climate, right? So then next, water vapor. Water vapor is a kind of greenhouse gas, right? So that is due to the increase in the Earth's temperature, right? Earth temperature, and more water gets evaporated from the water bodies, right? And stay in the atmosphere, adding to global warming. So the next, melting permafrost. So permafrost is frozen side, right? So that has environmental gases trapped in it for several years and present below the Earth's surface. So it is present in glaciers also. So as the permafrost melts, so what happens? It releases the gases back into the atmosphere and increasing the Earth's temperatures also. So that is the main reason. And then next we are going to forest blaze. Forest blazes. So forest blazes are forest fires. So those are emit a large amount of carbon containing smoke, right? So these gases are released into the atmosphere and increase the Earth's temperature, that is resulting in global warming. So these are the man-made and natural causes of the global warming. And now And also some of the effects of global warming is also major effects. Those are rising temperatures, threats to the ecosystem, and climate change and spread of diseases and high mortality rates and loss of natural habitats. So these are also the effects to the global warming, right? So now wait. Now, next topic is carbon cycle. So carbon cycle is an element found throughout the globe or universe. So the carbon is virtually important molecule in the carbon cycle, right? So of course, it percentage is less compared to the other gases, right? So it is found in all living things. And without carbon, what happens? There would be no life on Earth, right? So the characteristics of the remarkable carbon atom makes possible the compounds that are necessary for life on Earth. Right? So, and carbon is also part of non-living things such as the oceans, rocks, and also limestones, animal shells, and the atmosphere. So you see here, what is the carbon cycle definition? The circulation of carbon from atmosphere to biosphere, hydrosphere, lithosphere, and returns back to its atmosphere. So that is called carbon cycle, right? So what happens here? Carbon does not just stay in one place, right? So however, it's always on the move, right? So carbon atoms continuously move through. So living things, the oceans, the atmosphere, and the crust of the earth, right? So this movement is known as the carbon cycle, right? So why carbon cycle is important? Because many elements have cycle, right? But the cycling of carbon atoms is particularly important. So because through the photosynthesis and respiration, so it is the way the earth produces food and other renewable resources, right? So the carbon dioxide plays a key role in trapping heat in the atmosphere, and one of the basic mechanisms behind the greenhouse effect. And carbon plays a central role in combustion, right? And through decomposition, it serves as the Earth's waste disposal system. And also, in addition, the carbon cycle is important because carbon-containing gases in the atmosphere affects the climate, right? So increased carbon dioxide in the atmosphere, it has been responsible for more than half of the climate warming observed in recent decades, right? So now you see here carbon dioxide, it means one carbon and two oxygens. So that is called carbon dioxide. Carbon dioxide molecule is made up of 1 part of carbon and 2 parts of oxygen, right? So from the atmosphere, the carbon dioxide enters into the plant through which one? Photosynthesis, right? Photosynthesis to synthesize food particles, right? So now what is the photosynthesis? Photo means up to here photo means light. Synthesis means putting together, right? So 4% synthesis. So these two words are the Greek words. So photosynthesis is the process by which the plants or leaves prepare or make their own food using carbon dioxide, water, and sunlight. So, and in the absence of sunlight, a plant cannot prepare its own food, right? So sunlight is absent. What happens? So these plants cannot prepare own food, right? So during photosynthesis, this carbon dioxide is taken into the plant and changed into the plant food. So the carbon is then stored in this food, right? So when these green plants undergo the process of photosynthesis to make food, they absorb carbon dioxide from the air, right? And plants, they fix the carbon dioxide in the process of photosynthesis. And it is made to carbohydrates, proteins, and also other kinds of organic compounds such as glucose, right? So then next, how the carbon dioxide enter into the animals, right? So now you see here, the carbon dioxide enters into the terrestrial organisms when the plants are eaten by them, right? So the carbon elements stored in plants is then transferred to the animals when those are eating the plants, right? So what happened here, the plants are eaten by these animals, the carbon transferred to the organic compounds of the animals. Then next, how do carbon dioxide enter into the soil? So now, when huge amount of trees got buried, right? So like this, under the soil by the earthquakes or some other reasons. So it forms coal, right? So coal is a large deposit of forest under the absence of air in high temperature. It forms the coal, right? CO, air, coal. So the certain carbon is trapped in the form of coal in the ground. So the even certain animals which got buried under the layer of soil from the petroleum. It's called petroleum. Right? So the organic compounds that are formed from the air by photosynthesis from the plants to the animals. So these organic compounds, when they got buried in the soil, they form the fossil fuels like petroleum and coal, right? So whatever the fossil fuels we're burning right now using for other various uses, right? So all these fossil fuels are the carbon compounds. So petroleum is a carbon compound, right? And coal is a carbon compound. So these two are the carbon compounds. So when the plants and animals are dying, their dead bodies are released the carbon dioxide into the where? Soil, right? So now, how to enter into the carbon dioxide in the water? So now you see here, the carbon dioxide, when carbon dioxide enter into the water as carbonates, which are helpful for this aquatic plants or aquatic to perform photosynthesis, right? The aquatic plants. So the carbon dioxide which dissolve in the water, it falls the carbonates in the water, right? So now limestones and also the rocks, carbon is also available as limestone, that is called CaCO3, right? So an even greater amount of carbon that is stored for millions of years is incorporated into the shells, right? For marine organisms. Of marine organisms. So when these organisms die, their shells sink to the ocean floor and sediments cover them. So forming cemented together to this form limestone. Okay. So the organic compounds in the animal, in certain sea animals, the shells are made up of carbonates. So that is calcium carbonates, right? So in the living organisms in animals, how the carbon is there? So that is animals' bodies, even animal bones, right? So that is your bone made up of. Now, what is your bone made up of? Bone is a salt of calcium, right? And it is a salt of carbon. So carbonate salts, that is calcium carbonate and calcium phosphate. So your bones are packed up with, what is that? Carbon. Okay, carbon. So your cells are made up of carbon compounds like proteins, lipids, and carbohydrates. So the carbon compounds are the organic compounds. They form the organic compounds in the bodies of the animals and plants, right? Now, how carbon dioxide returns to the atmosphere? So up to here, carbon entering. Then next from here, return to the atmosphere. How? So now you see here, proof from fossil fuels and from respiration of animals, from burning of wood, from motor vehicle, from cement manufacturing and so many industries, and also from deforestation. So now you see here, so from fossil fuels, when these plants or animals, so they die, they decompose like this, right? They decompose, then they get decomposed the carbohydrates and other compounds and carbon dioxide. So that is released into the atmosphere, right? So when here carbon is being moved through decomposition, right? So that is because when plants and animals are dead, so their bodies decay, carbon dioxide is released into the air and carbon moves back into the air, right? So this is the from fossil fuels. Then next, from respiration of animal. So carbons and they move through respiration during respiration. So animals takes in oxygen and breathe out carbon dioxide, right? So wherever these organisms, even though they are living, so they carried out respiration, right? They carried out respiration in their bodies. So they are released the carbon dioxide out, right? So the carbon dioxide is released by the plants and animals when they are living, when they are dead, when their bodies is decomposed. The carbon dioxide from the plants and animals escapes into the air, right? So in this way, they reaches back into the atmosphere. So remember the photosynthesis and respiration. So these are essentially opposite of each other, right? So photosynthesis, what is this photosynthesis? Photosynthesis removes carbon dioxide from the atmosphere and replace it. What is that? Oxygen, right? But in respiration, takes the oxygen from the atmosphere and replace it with carbon dioxide. So opposite, right? So these are the opposite of each other. So however, these processes are not in balance, right? These are opposition. So now from burning of wood, that is called combustion, right? So the process of burning of or combustion may return the what is that carbon in oil, coal, and also natural gas and wood to the temperature, right? So in combustion, organic molecules are rapidly oxidized and converted to carbon dioxide and water with release of light and heat. So you see a burning wood releases carbon stored over the previous decades in one quick burst. For an equal amount of heat or electricity, it releases more carbon dioxide in the air from burning wood, right? So this should be reabsorbed as trees regrow, right? So this is the from burning of wood. And then next, from motor vehicles and industries. So motor vehicles. So modern transportation relies heavily on petroleum and passenger cars and light duty trucks, right? So they contribute half of the carbon dioxide emissions from the transportation sectors, right? So burning 1 gallon of gasoline creates about how much? 20 pounds of carbon dioxide, which means the average vehicle creates roughly how much? 6 to 9 tons carbon dioxide each year, right? And from cement manufacturing. So there are two major sources of carbon dioxide emissions. The primary sources are total, that is 60%. 60% of total emissions is the calcination of limestone, that is CaCO3. CaCO3. So when heated to above 900 degrees Celsius, that is converts to pig lime, CaO, releasing carbon dioxide into the atmosphere. So cement is an important construction ingredient produced in virtually all countries all over the world, right? So carbon dioxide is a byproduct of chemical conversion processes used in the production of clinker and a component of cement, and which limestone is converted to lime, right? And deforestation. So this is also very, very, very important. So deforestation means trees and other plants absorb carbon dioxide from the atmosphere, right? as the group. So this is converted into carbon and stored in the plant branches, leaves, and also trunks, roots, and in the soil. So when forests are cleared or burned, so what happens is that the stored carbon is released into the atmosphere, mainly carbon dioxide. So that is also main reason. And now you see here in this diagram, we see the exchange of gases, right? Exchange of gases. So carbon dioxide and oxygen between plants and animals, right? So you see here, so carbon dioxide is going out and trees are releasing oxygen and you can breathe this oxygen, right? So all of you listen carefully. So everyone or everybody plants some plants, in a house or your schools or your colleges, any place, any place, at least one plant you can plant, right? So this is the global warming and carbon cycle, right?